Many people think constraints are the enemy. They believe that if you remove limits, you will get the best possible result. They imagine a world without boundaries where anything is possible. But research in optimization, physics, and artificial intelligence suggests the opposite is true. Constraints are necessary for validity. Without them, you have infinite possibilities, which means no direction. In the world of engineering and business, we often confuse technical limits with business limits. We worry about latency, memory usage, or bandwidth. But the real killers are budget, timeline, and team capacity. These are the three constraints that determine if a project dies before it ever starts. Here is the thing. When you start a project, you usually think about what you want to build. You imagine the features, the cool technology, the perfect solution. But you skip the hard part. You skip the boundaries. Think of a sculptor working with marble. The marble itself is a constraint. The sculptor cannot create something larger than the block. They must work within the material. If they ignore the material, the statue falls. In business, the material is your resources. You have a certain amount of stone to carve. If you try to carve a mountain with a chisel, you will fail. This is not about limiting your vision. It is about respecting the reality of the materials you have to work with. Let us talk about feasibility. This is often about money. Can we actually afford to build this? Not just the initial cost, but the ongoing maintenance. In the field of mixed integer linear programming, constraint reasoning is essential for generating explanations of infeasibility. This means you need to know why something cannot happen. If your budget says $500,000 and your plan requires $1 million, you do not have a plan, you have a dream. Feasibility forces you to ask if the technology exists and if the cost aligns with the value. It is the filter that stops you from building things that are too expensive to sustain. When you define this constraint early, you prevent the architectural failure that comes from over-promising and under-delivering. You stop chasing solutions that cost more than the value they create. Then, there is desirability. Just because you can build it, should you? This is where large language model research offers insight. They emphasize integrating high-level user intent with domain-specific rules to prevent hallucinations during planning. If you build a tool that solves a problem nobody has, you have wasted your time. Desirability is about the human need. It is the difference between a fancy car and a reliable vehicle. You need to know what is actually needed before you write a single line of code or pour a single cubic meter of concrete. This constraint prevents the trap of building solutions looking for problems. It forces you to validate that the output matters to the people who will use it. When you align your build with genuine need, you ensure that your effort is not just technically impressive, but actually useful. Finally, consider viability. This is about your team and your timeline. Can you keep this going? Research into complex systems shows that constraints serve as resolution rules that reduce the search space. For humans, this means knowing how much time you have and how many people you have to do the work. If you commit to a timeline that requires your team to work double shifts for a year, the system will fail due to burnout. Viability ensures that the effort sustains the effort. It is the balance between ambition and reality. Without this constraint, you start a marathon but run out of water halfway through. You finish the first mile, but you never cross the finish line. A project that cannot be maintained is a project that is already dead. Now consider this. Some researchers talk about a multi-dimensional framework for instruction following. They suggest that structured constraints significantly boost performance as complexity increases. This applies to you too. When you face a complex project, you need rules to follow. These three constraints act as those rules. They reduce the search space for your decisions. Instead of wondering what to build next, you know what is allowed. This turns constraints from a limitation into a catalyst for creativity. You are forced to find innovative solutions within the boundaries. You stop trying to do everything and start doing the right things. Identifying these constraints early prevents costly rework. Shifting focus from how to build to what is actually possible changes everything. In game strategy, you cannot win if you do not understand the board limits. In physical modeling, you cannot predict motion without defining the forces at play. The same logic applies to your projects. If you ignore budget, timeline, or team capacity, you are building on sand. The architecture will fail not because of bad code, but because of bad planning. The system breaks under the weight of its own ambition. So, before you build anything, write these three down: feasibility, desirability, and viability. Check them against your plan. If one is missing, you're not ready to start. This is not about limiting your vision. It is about ensuring your vision survives. The most effective constraints are self-imposed mental frameworks that define the problem space. They are the walls that keep you from walking off a cliff. By accepting them, you gain the freedom to build something that actually works. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.